All right, Pre-Cal 11, here we go. So welcome to the first of many video e-lessons. I'll do my best to go slow. I want to hit some key points and I want to do a few examples with you. A reminder, all of the detailed answer keys and detailed notes are already on the website, but this just provides you with a little bit extra. I'm hoping it supplements the in-class experience. Obviously it won't be the same, but we'll do our best. So probably the most important thing to remember is that you can go back and watch this again and again and again. So if there's something you're confused about, if I go too quick, just rewind, watch it again. If you still don't get it, shoot me an email. Okay, we'll try my best to clear things up. So here we go. Section 3.1 is properties of rational expressions. Now, this might be a little redundant because we've seen this before, right? We've seen fractions before. We've also seen this in section 2.3 where we graphed rational expressions, but here we're going to deal with them more mathematically. So probably the most important part of a rational expression is what's the domain of the function, which means what are the values of x that satisfy the equation. Now in a rational expression, since we have the b value, right, we have a denominator, what we need to know is what makes that denominator 0. Because if your denominator is 0, you can't exist, right? The rational expression does not exist. And we call those the undefined values. So if you look below here at the first couple examples, they're rather straightforward to find out. Here, you have 2 over x. Well, obviously, what can't x be? If we don't want the denominator to be 0, it can't be 0. That's it. Done. Now for the next question, x minus 3. Now we don't care about the numerator. We'll get to the numerator in probably section 3.3, 3.4. What the denominator tells us is what x can't be, what our restriction is. So what we're trying to solve is essentially this. X minus 3 equals 0. What is x when that is 0? And a bit of algebra tells us that x would be 3. So you'll see on the right side here, we just say that x cannot equal 3. So far, so good. Now, in the next question, this should stick out to you. Difference of squares. X squared minus 9 factors to x minus 3 and x plus 3. So we have two scenarios where we'll get 0 because if the left side equals 0, right, what's x? Well, x is positive 3, so that's not allowed. Sorry. Positive 3, and here x is negative 3. So we end up with two solutions. X can't be positive 3 and x can't be negative 3 because if you plug it in here, you're going to get 0, and that's not allowed. Now the last one in the list, I'm hoping is intuitive, but at the same time this is an area where you can get tripped up. You have x squared plus 9 equals 0. Well, if we just do some algebraic manipulation here, you get x squared equals negative 9. Can you have a number and square it and end up with a negative result? Absolutely not. Not possible. So we just say that. There are no possible values. Sorry, switch to the highlighter here. There are no possible values of x that will make this 0. So there's no undefined values. That relation or that rational expression would exist at all points. So that's what we're getting at, right? And what this does is it gives us an accurate telling of the rational function. It helps us graph them like we did. And we can simplify them, which we're going to look at in 3.2. Right now I just want to focus on the properties of them. So far it's about where is that denominator 0. That's the most important aspect so far. So let's just do a couple examples here. Simplify. So if you can simplify, it means you can cancel out the denominator or pieces of the denominator, right? And in 2.3, it gave us our asymptotes, it gave us our wholes. When we canceled it out, we got wholes. When we couldn't cancel it out, we got asymptotes. So let's have a look. We have 3, sorry. We have 3x minus 3 over 6x minus 6. Both of those, numerator and denominator, you can simplify. Top, factor out a 3. You're left with x minus 1. On the bottom, factor out a 6. You're left with x minus 1. So when we were graphing in 2.3, the denominator here, this x minus 1 would say we have an asymptote at x equal 1, but since they cancel out, we actually would only have a whole. And we will probably see more of that in section 3.4. So what are we left with? 3 over 6, which is 1/2. Now, I don't want you to concern yourself too much with what that 1/2 means. In reality, our equation looks like this. So we end up with y equals 1/2, which means our graph is just a horizontal line at a half. But let's not worry about that right now. All right, moving on. Example here. So simplify the top, no can do, x minus 2. Simplify the bottom, yes, difference of squares, right? So x minus 2, x plus 2. If it helps your brain, put brackets around it. Now, can we cancel anything out? Sure we can. Boom, boom. What are we left with? 1 over x plus 2. Simplified. And then, yeah, this would be an asymptote at x equals negative 2 from our graphing. Next one. Okay, so now we're dealing with all letters, no numbers. This actually won't give us any sort of graphing qualities because we have y's in there as well. So we're only going to look at this as a simplification statement. So can you factor out any common factors? On the top, x and a y from both. So x, y. What are you left with on the inside? You're left with x plus y. On the bottom, factor out a y. And you're left with x plus y. So cancel, 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 cancel. What are we left with? Just x. So those are our simplified forms. Yeah, we got simplified from the previous example, and we have simplified. So that is what we're pushing towards right now. Couple more. So we're looking at factoring. So factor this top one, right? Two numbers that multiply to negative 6 and add to negative 1. Well, that's negative 3, positive 2. So the top factor is 2. X minus 3, x plus 2. Bottom again, we got a difference of squares. X plus 2, x minus 2. What cancels? Boom, boom. What are we left with? X minus 3 over x minus 2. And that is an asymptote at 2. We're rolling. One more. Now on this last one, the top is a difference of squares. So x minus 3, x plus 3. Two numbers that multiply to 12 and add to negative 7 is going to be both negatives, negative 3, negative 4. Cancel, cancel. We're left with x plus 3 over x minus 4. And now again, asymptote at x equal 4. So, simplifying. That's all we're doing right now. Now, if you look below here at these common errors, never, ever do that. No, 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 no. You can't cancel those two x's because this is not x cancel x, right? You need to think about this as what it actually is, right? It's x over x plus 1 over x. You can't just cancel the x's out because you just end up with 1, and that's not what you have. No can do, don't you dare. Same here. No, 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 don't do it. Same here. No, no, no. Like, it seems intuitive, don't do it. And you can't cancel the 2 and the x, you can't cancel the 9 and the 3 on the bottom one, all right? You can only cancel out factors, all right? So, that's it. What I'm going to do for you is I'm going to solve one of these questions. Let's do number 20. So, on the top, two numbers that multiply to 18 add to 9. I have x plus 6 and x plus 3. On the bottom, factor out an x, and you have x plus 6. Boom, boom, you're left with x plus 3 over x. Asymptote. You don't need to tell me this, but I'm just doing it for extra. at x equal 0. So work your way through the book, try the questions, you got detailed answer keys online, and final answer key at the end of the page. So continue to work through this stuff. Video 3.2 is up, so you can watch that whenever you want. And keep on keeping on, guys. Hopefully everyone's safe and healthy. All right, see you later.